So welcome in the next part of our video series on refraction of light, and in this video let's start with a bit of a recap, right? So we have learned so many things about refraction of light, and now let's have a bit of a recap to summarize all the things that we have learned, and let's see how these things are used in the topics that are further in our chapter. Okay, so let's have a bit of a recap, right? Let's have a bit of a recap. So these are the things that we have learned. These are the things that we have learned till now in our video series. So first was refraction. What is refraction? How does the refraction happens and why does it happen? We all know that light bends towards towards or away from the normal when it hits a medium that is optically denser or rarer than where it was coming from, and this particular phenomenon is called refraction of light. And this happens because the light slows down in the particular medium, right? Now we defined a certain quantity that was refractive index, and the formulae and the relations that was called Snell's law is written in front of you. We use these, we solved some numericals and stuff, and I will highly encourage you, if you haven't watched these videos, then do give them a watch and then come to this video to learn where all these concepts are getting used, right? So we learned all of these. We learned that I and R have this constraint. We saw these things with the simulations as well, right? And then we learned what are optically rare things and what are optically dense things, right? And the crucial thing that we learned in the last video is when light moves towards, from a rare medium to a dense medium, it refracts towards the normal, and when light moves from a dense medium to a rare medium, I should have, yeah, dense medium to a rare medium, then it refracts away from the normal, right? So these are the things that we have learned till now, and now we are going to see how are these concepts used in the real world. It's going to be super amazing, so stay with us. Okay, now, have you seen a magnifying glass before? Magnifying glass or lens, right? You have of course seen it. You have used it to enlarge your textbooks and stuff. You have some of you might have even used it to burn paper from the sun, right? How does it do that? How does it magnifying glass work, right? Lens and spectacles, right? A lot of people in the world wear spectacles to see clearly. They cannot see clearly from their eyes, and they are prescribed glasses from the doctor. And how do those lenses work? How do those lenses make us see clearly? That's a really good thing to know, right? Because a lot of people wear spectacles. You must know people around you, your friends must, one of them must wear spectacles, right? So how do they work, right? Binoculars, right? Binoculars, telescopes. When I was a kid, I used to be fascinated from them. Like, how do they allow us to see things that are so far away, right? Like I can sit here and I can see Mars, I can see the moon, I can see Venus, I can see Jupiter or Saturn, right? So how do they work? So the concepts that we have learned are so crucial that without those concepts these things wouldn't exist. Binoculars, telescopes, your glasses, magnifying glass, no such thing would exist, right? So now is the time that we learn what are the things that allow us to do the implementation of the concepts that we have learned, and now we are going to do this. Okay, so the thing, you might have read this in the bottom of the screen, that is lens, right? That is lens. So lenses are quite crucial. Lenses are quite a crucial part of anything, be it binoculars, be it telescopes, be it glasses, be it magnifying glass, right? So what is a lens? What is the definition of a lens? We are going to study that. So a transparent material. A transparent material, this is the definition that is given in your book, by the way. A transparent material bound by two surfaces, okay, of which one or both surfaces are spherical. Spherical, interesting. How can be a surface spherical? How can be a surface spherical? Don't you think our earth is spherical? Our earth is spherical, right? Our earth is spherical, but it's saying that the surface of the this transparent material is spherical. So how is that? It's not plane. If it was plane, then of course it wouldn't have been spherical. So that thing is called a lens. That thing is called a lens. That thing is called a lens. That let's talk about it a bit more. Okay, this is the major types, but let's just put it down for a bit, and let's talk about what spherical surface mean, right? What spherical surface mean? So let's say we have this particular sphere. Let's pretend that it's a sphere, because for now it's just a 2D circle. Let me try and see if I can. Oh, okay, no, that didn't work. Okay, please write, and let's say if I do that and try to align it. Oops. Okay, now it looks like a sphere. Right? It looks like a ball, perhaps, right? So if I take a chunk out of it, if I take a piece out of it, okay, sometimes balls, the balls that we play with, our cricket ball, get tears, get it tears off, and maybe a chunk of it gets separated from the main ball, and that ball would look like this. It would look like something like this. It would look like, right? It would have a bit of a contour in between, and a belly sort of in front of it, right? And it is saying that the surface, so it's a spherical surface, because it has come from a sphere. It is a sphere, right? It is a sphere. So any chunk that comes from a sphere would be called spherical, right? And maybe let's say it said that it bound by two surfaces. So let's say it has another surface. Let's say it has another surface, and it forms a shape like this. And it looks pretty much like a lens. But some people would say that, oh, why did you connect the pit part of the lens? Why didn't you try and connect the bulged part, right? This was the bulged part, this was the pit part, right? So if I try to connect the bulged part, then we'll get some sort of a shape like this, right? Which is thin from the middle, and is bulged out in the top and bottom, which is quite opposite of this particular shape, that is bulged from the middle, and it is quite thin on the top and bottom parts, right? So when we do these things, when we find these things, that take the part of a sphere and then combine them in two different ways, we get two type of lenses, and now we are gonna study those. Okay, so this was just to understand that what a spherical thing means, which we learned that any chunk that comes from a sphere would be called spherical, right? So now this particular two types of lenses are called, one is called convex lens and one is called concave lens, which has some rooted language kind of meaning, but I would tell you another meaning which will make much more sense. Okay, now when we shine a bunch of rays towards our convex lens, right? So let's say this is the middle point of our convex lens. Let's say this is a line that passes through the middle point, right? Now if I take if I take a light ray, then what will happen? If I take a light ray parallel to this particular line that is going through the middle point, then we see that it converges the light. Right? And if I take a light from the below part, then it shouldn't do anything different, and it will also converge. Oops, I made a curve. I should be a line. Right? It also converges, right? Okay. But something different happens. When we talk about a concave lens. Something different happens. What does happen? Some of you might have guessed, because these two are opposite of each other. Then what will happen? Let's put it to 0 degrees. Okay. Then what will happen? So what happens is, it goes and let me make it parallel, and it diverges. It diverges from the middle line that we drew. Okay. So based on these observations, right, we shown a bunch of light towards these lenses, and they showed these kind of behaviors. So based on these observation, let's first write that these lenses let's have a proper separation between these, right? First let's have a proper separation between these. Okay. So these lenses, okay. Now these lenses are called, these lenses are converging light rays, and these lenses are diverging light rays. So based on these, we call convex lenses convergent lenses, right? Convergent lens. Okay. And what do we say? And let me just confirm if it is called convergent, or let me just confirm, right? Transparent material bound by two surfaces, convex, and converges, and called converging. I'm sorry, not convergent but converging. What, you get the idea, right? Converging lenses, because they converge light. And these are called similarly diverging lenses, right? So how cool are these lenses? What do they do, and how do they work in our telescopes, or our glasses, or our magnifying glasses, right? That we will see in another video, because for that we'll have to see some terminology, we'll have to see some definitions around these lenses that will help us see how the images gets formed, right? If I take an object here, maybe, so what is the image that this object will make, right? So there's a lot of terminology that we'll see in another video, and just for this, I have recapped all of it, and if you have any doubt, then please let me know in the comments, and I will meet you in the next one, where we'll see lenses, a lot of terminology, and then we'll see how images are formed, and then we'll get to know that how are these lenses used in a lot of devices. So thank you so much for watching, and I'll see you in the next one.